Let's practice using the periodic table to determine the quantum numbers for a specific electron. This question asks, what are the quantum numbers for the outermost valence electron of chlorine? So chlorine, you can see, is outlined in purple on the periodic table. And let's go through and identify each of the quantum numbers. Let's start with the principal quantum number. We can determine this quantum number, n, by looking at the periodic table rows. So we can number the rows 1, 2, 3, and we see that chlorine is in the third row of the periodic table. So n equals 3. Next is the angular momentum quantum number, or L. This tells us which subshell our electron is located in. And again, using the periodic table, we see that on the left, first two columns, we have our S subshell, and we know the right side of the periodic table, we have our P subshell. But how do we denote that? Because it needs to be a number. So S equals 0 and P equals 1. So L equals 1 for this quantum number. Our next quantum number is the magnetic quantum number, or M sub L, and this determines the specific orbital that our electron is located in. And we can denote this or identify these areas of the periodic table with -1, 0, +1, -1, 0, +1 for the P subshell. And when we look at the column where chlorine is located, we see that M sub L will equal 0. And if we go ahead and draw a P orbital, we've got those 3 specific orbitals in the P subshell. And so the one to the left would be -1, the middle would be 0, and the right would be +1. So that's how we can identify those numbers. The final quantum number is the electron spin, or M sub S quantum number. This tells us the direction of the spin of our electron. So is it a downward or upward spin? So let's go through and give an example. So for chlorine, we have aluminum, which would be spin up, silicon, which would be spin up, phosphorus, spin up. And now after filling each orbital separately, we go back and pair them up. Sulfur would be spin down, and chlorine would be spin down, which is -1/2.